all wavelengths to identify the specific wavelengths where our solution has max absorbance. And two examples of this is identifying a specific protein or analyzing the purity of a solution.
Here is a picture of one of our spectrophotometer results while I explain what a lambda max is. The highest point on the graph is your lambda max, or where your sample absorbs the most light.
Concentration and absorbance are directly proportional to each other, so when you increase one, the other one will also increase.
Here I've written down the Beer-Lambert's law and what it means and what it stands for. The E, or the Greek symbol for epsilon, stands for molar absorptivity. The L stands for the length of the light path, and C stands for the concentration of the solution, which, when multiplied together, gives you the absorbance value. This equation can be rearranged in any way to help you find any of the values listed in the equation. The next few clips are of us putting the solution into the cuvette so it can be scanned in the UV vis room. First you put the solution you gathered in, then you put water in to dilute it so it can be measured properly. After we put the solutions into the cuvette, we headed to the UV vis room to use the spectrophotometer. First, you clean off two sides of the cuvette using a Chem wipe, then place the two clean sides in the cuvette the way the light will shine through it. Then you make sure you zero the spectrophotometer by using water, which is what we did here. Now that our machine was zeroed, we can now start putting our solutions in to measure the absorbance value. This is Adam cleaning the cuvette and putting it in just like I did with the water. This is us scanning the absorbance value of the solution. Now we repeat this process for the two other solutions we have, and after we scan our absorbance value, we make sure to write it down in our notebook so we'll have the data. While showing a picture of our notebook with all of our absorbance values we gathered, I'm going to explain why we zeroed the machine with a blank or water. Use zero to account for background or previous absorbance from other groups, so you'll have accurate measurements. Now that we recorded all our absorbance values, we went back to the lab to clean up our lab station, and this is what we can be seen doing here. We made sure to throw away our microcolumn into the glass trash bin, and this is me pouring our waste into the waste container like we're supposed to. We also cleaned our glassware, which can be seen here.